In this video, I will be solving a linear programming problem using Solver. I'm assuming that you know or you are familiar with Solver, and also you have uploaded Solver in your Excel. So the problem I'm going to explain says a company hauls gravel to a construction site using a small truck and a large truck. The carrying capacity and operating cost per load are given in the accompanying table. So here we have the table. So we see the capacity of the small truck and the large truck and the cost per load in each of these trucks. The company must deliver a minimum of 120 cubic meters per day to satisfy his contract with the builder. The union contract with his drivers requires that the total number of loads per day is a minimum of 6. So here we have two constraints. So the company must deliver a minimum of 120 cubic meters per day. And also the total number of loads per day is a minimum of 6. How many loads should be made in each truck per day to minimize the total cost? Because they say here how many loads should be made in each truck per day. So it will be a good idea to see X1 and X2 because we have two trucks. X1, the number of loads in the small truck, and X2, for example, the number of loads in the large truck. So X1 will be the loads in the small truck and X2 the loads in the large truck. And obviously, then the cost that we need to minimize, it will be depending of the number of loads. So we can define the cost taking into account the number of loads. And we have here the cost per load. And we know that X1 is the number of load of the small truck, and the cost of each load is 73. So 73 X1 will give me the cost for hauling the gravel in the small truck. And 52 times X2 will give me the cost in the large truck. So the cost will be, the thing that we are going to minimize the cost will be 73 X1 plus 52 X2. So 73 times the number of loads in the small truck plus 52 multiplied by X2. So we have the function that we need to minimize. This is the objective function. And now we need to know how to write the constraint in the function of this variable. And I notice that one constraint is the number of cubic meters that we need to deliver and how much we deliver. So we deliver the number of loads in X1 multiplied by the capacity of this small truck. So if I multiply 30 times X1, that's gonna give me the amount delivered in the small truck. And if I want to know the amount delivered in the large truck will be 40 times X2. So the amount delivered will be equal to 30X1 plus 40X2. So that gives me the amount delivered, and I know this will be one constraint. This need to be more or equal than 120, because minimum we need to deliver 120 cubic meters. And finally, another constraint here is that the number of loads need to be minimum 6. And the number of loads obviously will be the number of loads of the small truck, and the number of loads of the small truck is X1, and the number of loads in the large truck will be X2. So the total number of loads will be X1 plus X2. So the total number of loads will be X1 plus X2, and I know that this need to be more or equal than 6. It need to be minimum 6. So we have here two constraints. So we need to minimize this function subject to the constraint that 30x plus 1 plus 40x2 need to be more or equal than 120. And also that x1 plus x2 need to be more or equal than 6. So we have here the two constraints. And obviously, x1 and x2 need to be greater or equal than 0 because the number of logs cannot be negative. So we have then the other constraint that the variable, the independent variable, cannot be negative. They need to be at least 0. So we have solved the problem so far. The only that we need is to get the answer. And to get the answer, we need just a right tool. And a good tool is definitely Excel Solver. So I'm going to open Excel Solver. And opening Excel Solver, I'm going to make step 1, 2, and 3 of using Excel Solver for solving an optimization problem. And we know that they are is choosing the cell for the variables and entering the function for the cost and entering the function for the constraints. So I'm going to open Solver. I'm using here A1 and B1 as the label for the variables, but actually the cells that I'm going to be using as independent variable will be A2 and B2. And I'm going to be using D2 as the function for the cost. I'm using just D1 as a label of this, and the constraints will be in this column F. And I'm going to be using these two functions of the constraint that we have here. Okay, here I'm going to type the function for cost. That is 73 times A2. I choose A2 for this, and I type here plus 52 times B2. So B2, remember, is the key for the X2. And for the constraint, I type here the first constraint, that is 30 times X1, so 30 times A2 plus 40 times B2, and type always an enter. So when you type enter, that is going to give you a 0 because these X1 and S2 are 0 so far. So you haven't entering anything in A2 and B2. So it means that at that moment Excel is considering this as 0. So for that reason, when you press enter here, you're going to see a 0. And again, you type the first constraint and press enter, and you're going to see a 0. And then type the second constraint, that will be equal A2 plus B2, and press enter, and it's just going to give you a 0 there. So this is actually step 1, 2, and 3 of using Excel for solving an optimization problem. Step 1, choosing the cell for the variables. Step 2, choosing a cell for the objective function. And step 3, choosing the cell for the constraint. It could be whatever cells, by the way. Okay, then open Solver as the fourth step. Open Solver, that you know that is just clicking here in data that you are going to see in your Excel window, and then when you see the set of options that appears after you click this data, you are going to choose Solver. Remember that you need to download this Solver, this add-in first. You need to have it in your Excels. Okay, so click in Solver, this here, and it will be open Solver. As a step 5 and 6, remember, fill the Solver windows with the information of the objective function and variable cells, and choose Simple LP and click Solve. So this is what you need to do. Fill the Solver window, and just remember that D2 was the cell for the objective function, that it was in D2. If you put the cursor here, just click in the cells D2, and Solver will put here the D2. Choose also the changing variable cells and add the constraints. Remember, for adding each constraint, you need to click add first. I explained before how to add each of the constraints. So don't forget that the minimum must be selected. So select this minimum. Remember, in another video I explain how to add each of the constraints. At the end, the Solver window looks like this. So you need to choose make unconstrained variables not negative. With that, you will be sure that x1, x2 will be greater or equal than 0 in the solution. And also choose the simple LP method. So, and just press solve. Excel give you the solution. So I found here 0 and 6 as the value of the number of logs for the small truck and the number of logs in the large truck. You should keep solver solution, and this is as a step 7. So the company must make 0 loads in the small truck and 6 logs in the large one. And if you want to know what will be the minimum cost, this is given here in this cell. So this produces a minimum cost of $312. And this is the problem. I hope you have found it useful. Thank you.